Hello friends, welcome to RAAONLINE lecture series on renal physiology. This session we'll be seeing about renal function test. We have almost come to the end of the renal physiology. So we'll be summing up the functions of the kidneys and certain concepts involved in assessing the kidney function. So one such concept is this renal clearance, and along with that we'll be seeing about other renal function tests as well. Let's see the learning objectives. So this session will be covering renal clearance based mechanisms for assessing kidney functions. Apart from that, we'll be seeing about other tests like blood analysis. What are the blood tests, blood investigations that we are going to employ for identifying the renal diseases. Similarly, urine analysis and certain imaging techniques and some other special tests that are used to assess the renal functions. Now, what is this renal clearance? It is a concept that compares the rate at which the glomerulus filters a substance. The substance may be a solute or water. Okay, this rate is compared with the rate at which the kidneys excrete the substance into the urine. Okay, so this is the basic concept of renal clearance. It compares two things: the rate at which the glomerular filters the substance and the rate at which the kidneys excrete it into the urine. Okay, so we know that the three basic functions of the kidneys are glomerular filtration, tubular reabsorption and tubular secretion. Now let us see how a solute is being handled by the kidneys along its length. Okay, so this is the afferent arteriole which takes the blood, maybe the component of the blood here we call it as renal blood flow. Okay, and it takes into the glomerular capillaries. This is the tuft of the glomerular capillaries which is situated in the Bowman space, and it also carries the same blood which is not getting filtered, but that will be carried via the efferent arteriole. Efferent arteriole will be entering into another tuft of capillaries called as peritubular capillaries. Finally, the peritubular capillaries end up in the renal vein, and this is going into the systemic veins. Right. Now, what happens here inside the nephron is what is of our interest. Okay. So, some amount or some fraction of the blood is getting filtered into the Bowman space. That is called as GFR or tubular load. Here we call it as tubular load. That the load that is going into the tubules is called as tubular load. Okay. Now, what is this substance? Say for example, any substance Px. Okay. Maybe you take an example of any substance, say X. Okay. So maybe the concentration of the substance X in the plasma times the renal blood flow is what is flowing into the glomerular capillaries. The same is getting into the getting filtered into the Bowman space. Now, what happens to this filtrate tubular load when it passes through the nephron? Some amount of the substance may get reabsorbed into the peritubular capillaries. At the same time, some amount of the substance may get secreted back into the tubules. Okay, so the reabsorption can happen, secretion can also happen. Now, what is ultimately excreted in urine? This component. This component is actually influenced by the amount reabsorbed and the amount secreted. Okay. Say for example, the amount reabsorbed is represented as Rx. The amount secreted is represented as Sx. So what is excreted? We call it as Ux. Okay. So the solute that is excreted, Ux, we can represent this as Ux is equal to GFR, that is the filtered load, minus Rx, that is the substance or concentration of the substance that is reabsorbed, plus Sx, that is the concentration of the or the amount of the substance that is secreted. This is what is actually determining how much solute is to be excreted in the urine. We'll be seeing a lot in detail about this concept in the further slides.